morning friends. In semiconductor electronics, we are going to discuss about the more MCQ question. Now the first question is depends on to find out the intensity of the electric field in a depletion region. The potential barrier of 0.5 volt exists across a PN junction. If the depletion region is of 5 to 10 is to minus 7 meter width, the intensity of the electric field will be, where is it? So here the potential barrier is given V is equal to 0.5 volt and width of a depletion layer D is given 5 to 10 is to minus 7 meter. We have to find out the intensity of the electric field. We know the equation of the relation between the electric field and electric potential. E is equal to V by D. E is equal to V by D. V is given 0.5 volt upon width of a depletion layer 5 into 10 is to minus 7. So it is equal to 0.1 into 10 is to 7. That means the 10 is to 6 volt per meter is the intensity of the electric field exists in PN junction. Again, the potential barrier of 0.5 volt is exist across the PN junction. That means the electric potential is given 0.5 volt. If the depletion region is 5 to 10 is to minus 7 meter wide, the intensity of the electric field in this region is. So here the width of a depletion region is given 5 to 10 is to minus 7 meter. We require the value of electric field. So the equation showing the relation between the electric field and electric potential E is equal to V by D. V is given 0.5, width of a depletion region 5 to 10 is to minus 7. Therefore, intensity of the electric field E is equal to 0.1 into 10 is to 7 volt per meter. So that is the 10 is to 6 volt per meter. Okay. After that, we are going to start our discussion about the MCQ question depends on the logic gate. Before starting this question, first we just revise it. In AND gate, what is the characteristic? AND gate, all are 1, 1, 1, 1. If both inputs are 1, output is 1. Right? And Boolean equation is y is equal to a dot b. Y is equal to a dot b. While for the OR gate, 0, 0, 0, that is the characteristic. If both inputs are 0, output is 0. And Boolean equation is y is equal to a plus b. Now for NAND gate, characteristic is 1, 1, 0. 1, 1, 0. If both inputs are 1, output is 0 in case of a NAND gate. NAND gate is prepared by, if the output of the AND gate is given as the input of a NOT gate, that means the combination of AND plus NOT that gives the NAND gate. Right? And Boolean equation is y is equal to a dot b whole bar. Y is equal to a dot b whole bar. Now for NOR gate, characteristic is 0, 0, 1. If both inputs are 0, output is 1 in case of a NOR gate. NOR gate is prepared if the output of OR gate is given as input of a NOT gate. And Boolean equation of the NOT gate is a plus b whole bar. Right? Therefore, just I write down here. For AND gate, characteristic is 1, 1, 1. Boolean equation y is equal to a dot b. For OR gate, characteristic is 0, 0, 0. Boolean equation y is equal to a plus b. Now for NAND gate, characteristic is 1, 1, 0. Boolean equation is y is equal to a dot b bar. And for OR gate, 0, 0, 1. Boolean equation is y is equal to a plus b bar. We keep in mind this characteristic and also the Boolean equation. We can solve this objective question. How? Now, the combination of the NAND gates shown here are equivalent to. Here there are two circuits are given in part 1 and part 2. Part 1 represents which gate? Here the three NAND gates are connected like to this. When we discuss about the numerical of exercise, at that time we discuss the same numerical. If in AND gate and NAND gate and NOR gate, if the both inputs are short circuit or are combined with each other, so this gate act as a NOT gate. That is act as a NOT gate. Again, if both inputs of NAND gate or the NOR gate are short circuit or combined with each other, so this gates NAND or the NOR act as a NOT gate. Therefore, the equivalent circuit of one equivalent circuit of one is, there is the NOT gate, second is also NOT gate. Both is given as the input of a NAND gate. So we are going to prepare the truth table. Here there is not mentioned we have to prove by the Boolean equation or with help of a truth table. We can prove any method. We have to only give the answer, or we have to select the answer. This combination is act as which combination or the which gate. For that purpose, we prepare the truth table like this way. There is our input A and B. So output of this, there is the A bar, here the B bar. A bar and B bar. So inputs are 1, 1, 0, 0. Here 0, 1, 0, 1. Or we can add like this way, 1, 0, 1, 0. 1, 0, 1, 0. Here. One, zero, 1, 0. Okay. Now here there is the inverted A, there is the output of first NOT gate. Here also inverted B. So 1, 1, so there is the 0, 0, 0, 1, 0, 1. Now in B, output of this NOT gate, 1 becomes the 0, 0 becomes 1, 1 becomes 0, 0 becomes 1. These A bar and B bar are the input of this NOT gate. This. Now what is the Y? NAND gate, therefore A bar dot B bar and 1 bar. Right? Okay. What is the characteristic of NAND gate? If the both inputs are 1, at that time 0, otherwise 1. Both inputs are 1, so that is the 0, otherwise 1. Again, the NAND gate has the characteristic is both inputs are 1. At that time 0, otherwise 1. Both inputs of NAND gate are A bar and B bar. A bar and B bar is 1, therefore 0, otherwise 1. Right? So compare this output with our original input A and B. Forget the A bar and B bar. Here 1, 1, 1, 1, 0, 1, 0, 1, 1, 0, 0, 0. So there is the special output. We get the output 0 if both inputs are 0. Output is 0, both inputs are 0. So this combination is act as a OR gate. That is act as a OR gate. Therefore, the first circuit is equivalent to the OR gate. Now, next second circuit. In second circuit, first NAND gate as it is. Now the output of first NAND gate is given as the input of other NAND gate. So second NAND gate acts as a NOT gate. Second NAND gate acts as a NOT gate, like this. There is the first NAND gate, second is the NOT. So there is the one. There is the A, B, therefore Y dash, and there is the one. Again, in second NAND gate, both inputs are combined. Therefore, that acts as a NOT gate. Now, how we prepare the truth table? So, A and B are the inputs. Output of first NAND gate, there is the Y dash is equal to A dot B bar. And that is given as the input of a NOT gate. Therefore, Y is equal to A dot B whole bar, double bar. So we take the combination like this: 0 0 1 1 0 1 0 1. What is the characteristic of NAND gate? If both inputs are 1, output is 0. Both inputs are 1, output is 0, otherwise 1. So this output is given as the input of a NOT gate, again inverted. Therefore 1, that means the 0. 1, 0, 1, 0, 0, 1. So different output is this. So different output is 1 if and only both inputs are 1. This. Therefore, this combination acts as an AND gate. Therefore, first combination acts as a OR gate, second acts as an AND gate. From the truth table, we can prove it. OR gate and AND gate. Clear it? Okay. Now, next. For given combination of the gates, if the logic state of inputs A, B, C are as follows. A, B, C are, if the all three are 0, and second case is A, B is equal to 1 and C is 0, then what is the output of this combination? So that purpose we prepare the truth table like this way. First is the A, now B. That is which gate? That is the lower gate. Lower gate is, so there is the Y dash. Y dash is equal to A plus B bar. There is the input with C. C input. And then what is the Y? Y is equal to Y dash. And there is the NAND gate dot C bar. So first we prepare the truth table for this lower gate. A, B and C are given as A, B are first 0, 0 and next time both are 1. So there is the lower gate. Lower gate has the characteristic is if both are 0, 0 at that time 1, otherwise 0. Now listen, here there is the lower gate is given. Lower gate has the characteristic is output is 1 if both inputs are 0. Both inputs are 0, output is 1. Both inputs are 1, output is 0. Now C is also 0, 0. C is also 0, 0. Now, there is the NAND gate. NAND gate has the characteristic is if the both inputs are 1 at that time 0. Both inputs are 1 at that time the 0, otherwise 1 1. Otherwise 1 1. Again, there is the NAND gate. What is the characteristic of NAND gate? Both inputs are 1 and this time 0. But no, both inputs are 1, therefore both are 1. So the output of this combination is our D option is there. Again, here for given combination of gates, if the logic states of the input A, B, C are as follow, A, B, C is equal to 0, 0, 0. A, B and C are 0, 0. And A, B is equal to 1, C is equal to 0, then what is the output 1? So here first we prepare for this logic gate, NOR gate. What is the its Boolean equation? A plus B whole bar, that is the NOR gate. Now there is a combined with the C, and we obtain the output of NAND gate y is equal to y dash dot C bar. First A and B. First the combination of A, B, C are 0, 0, 0 and 1, 1, 0. So A and B are the input of the NOR gate. NOR gate has the characteristic is both 0 at the time 1. Both 0 at the time 1, otherwise 0. Now this y dash and C are given as the input of NAND gate. So this combination 1, 0, 0, 0 are given as the NAND gate. NAND gate has the characteristic if both inputs are 1 at the time 0, otherwise 1. But here both inputs are not 1. Therefore in both cases the output is always 1. That is the output of our given combination of the gate. Gate. Okay. Now next, which logic gate is represented by the following combination of logic gates? Here the A and B is given as the input of a NOT gate. Therefore there is converted by A bar, B bar. So inverted of A and B are given as the input of NOR gate. So what should be the output? 1. So this combination of the gate is act as OR gate. So we prepare the truth table for this. So that is our A and B. Now output of the NOT gate are A bar, B bar. That is given as the input of a NOR gate. Therefore output of NOR gate is y is equal to A plus B. A bar plus B bar whole bar. Again, the AB are the input. Output of the first NOT gate is A bar. Output of the second NOT gate is B bar. This A bar and B bar is given as the input of NOR gate. For NOR gate, the Boolean equation is A bar plus B bar whole bar. That is the NOR gate. Okay. Now the different combination of the inputs are 0, 0, 1, 1. That is the 0, 1, 0, 1. Now what is the A bar and B bar? A bar is the invert of A. That is the 1. There is also 1, 1, 0, 1, 0. Now, what is the invert of B input? B is 0, 1, 1, 0, 0, 1, 1, 0. There is the output of NOT 1 and NOT 2. Now, this A bar and B bar is given as the input of NOR gate. What is the characteristic of NOR gate? If the both inputs are 0 at the time 1, if both inputs are 0 at the time 1, otherwise 0. Both inputs are 0 is this, therefore 1. Now 0. So this gate is act as which gate? So here the different output is this 1. 1 is obtained for which case? If the both inputs are 1. Output is 1 if both inputs are 1. That is the characteristic of AND gate. Therefore, answer is this combination act as AND gate. Act as an AND gate. There is again A is given to the input as a NOT gate, B is also given as the input of a NOT gate, and output of both NOT gate is given as the input of NOT gate. We prepare the truth table for this combination of logic gate AB. Now A bar B bar is given as the input of a NOT gate. Therefore, Boolean equation of the NOT gate is A plus B bar. But here the inputs are A bar and B bar. Therefore, A bar plus B bar whole bar. Now, for two inputs, different four combinations of the inputs 0, 0, 1, 1, 0, 1, 0, 1. Now, output of NOT gate is inverted of A 0, 1, 0, 1, 1, 0, 1, 0. The same way, output of NOT gate 0, 1, 1, 0, 0, 1, 1, 0. Now, this A bar and B bar is given as the input of a NOT gate. NOT gate has the characteristic is this: both inputs are 0 at the time 1. Now both inputs are 0 at the time 1, otherwise 0. So that is the output of a NOT gate. Now for output of NOT gate, the different output is this one. One is obtained for which value of A and B? 1, 1. So that is the characteristic of AND gate. Output is 1 if both inputs are 1. So this combination is act as an AND gate. Clear? Okay. Now next, the Boolean equation for the circuit given as is. What is the Boolean equation of this circuit? Now listen, A is given as the input of NOT gate, therefore its output is A bar. Now that is the B. So that is the our OR gate. What is the Boolean equation of the OR gate? Y is equal to A plus B. But here the one input is A bar, second input is B. Therefore A bar plus B. Therefore Boolean equation Y is equal to A bar plus A bar plus B, because that is the OR gate. Now what should be the truth table? What should be the truth table? There is the A, B and A bar, and here there is the AND gate. Therefore Y is equal to A bar plus B. Different combination of the inputs are 0, 0, 1, 1. And here 0, 1, 0, 1. A bar is the output of NOT gate. That is the, what is the A is the input, inverted this. So 1, 1, 0, 0. Now there is the, which gate is given? OR gate. OR gate has the characteristic is 0, 0. At that time 0, otherwise 1. Right? So here both inputs are 0. These inputs are 0. Therefore output is 0, otherwise 1. Otherwise 1. So that is the output of this given combination. But that is not asked only we have to prepare the Boolean equation. But we can also prepare the truth table for this given combination. So as we keep the characteristic of all these four, our gates, AND gate, OR gate, NAND gate and NOR gate, and also its Boolean equation. So that is very easy to solve this numerical. Right? Depends on the logic gate. So generally the two objective question depends on the logic gate are frequently asked in board exam and also in competitive exam. So be careful about this. So very easy. Keep in mind the characteristic of AND gate, OR gate, NAND and also NOR gate. Clear?